implementing a monitor using the semaphore. Okay, so how we are going to implement the monitor? So we have already studied the concept of the monitor. Shared memory. So in that there will be some of the procedures. So those procedures we are going to call it as a functions. For example, if P1 and P2 are the two different processors, it cannot be able to access the same monitor at a single time. So because it is going to support the mutual exclusive concept. So here if that P1 is requested to do acquire the shared variables which is present in the memory, it cannot be able to directly access the shared variables which is present in the monitor. So it has to go through the procedure. So here we are using some of the semaphore values. Okay, so here we are going to a process must execute the wait before entering into the monitor, and it execute the signal operation after leaving the monitor. So we have know that what is the function of that wait and as well as the signal. It is used to lock the critical section. So for example, the particular process needs to enter into the critical section by the entry section, so it has to execute the wait operation. So then if it is needs to come out from the critical section to the exit section, it has to execute a signal operation. Okay, so here what are the variables we have used in by using the semaphore? So semaphore mutex, initially the mutex value is equals to 1. Next semaphore, next once it has completed the execution of task in the critical section, so next it will move on to the out, that is the exit section, it is going to be move out. Okay, so that value whatever if it is come out from the critical section, we have taken that value, that is the next count value is equals to 0. Okay, so this is the how we are going to the procedure it is look like. So in that monitor we have seen the shared variables and as well as the procedure. So here mutex is provided for the each monitor. So for example, here there will be two different monitors are there. Each monitor is associated with its own procedure and as well as with its own shared variable. Okay, so each monitor next it is used for the signaling the process. It has to wait until resumed process either leaves or wait the next count. It is used to count the number of processes is suspended. So for example, if we are using the two or more monitor or maybe a single monitor, so if particular P1 process it is utilizing the shared variable, so P2 has to must wait that until P1 can get the resources from the shared memory, so via by using the procedure, so then only the another process can be able to enter into the critical section, that is what it can be enter into the monitor by using the procedure. So here weight of mutex, body of the F. Okay, so here external procedure F it is replaced by here mutex. So here if next count it is greater than 0, then it can going to execute the signal of next or else a signal of mutex. So here if there will be a monitor, so in that monitor the only P1 can be able to enters into the monitor. So for example, we have initialized the value, so we are going to replace the procedure here. So if that count value if it is greater than 0, so then it will going to execute the next operation, that is what it can move from critical section to the critical section to the exit section. Next, resuming the process within a monitor. So we have seen that in the monitor, so we can resume the process. So for example, P1 is already entered into the monitor. So let me show that diagram. So for example, if P1 it has entered into the monitor. Okay, so what will happen if that P1 is entered into the monitor? So the monitor will going to make that particular P1 has to be suspended, or it has to going to resume that particular P1. So if that resume the process within a monitor. So until still it is not taken the whatever the shared variables and the procedure, it is still not taken or it is not utilized by the process. So in that time what is happening here, so all that process it going to be stopped in the monitor. So what are the problem we are going to face if that particular process it has stopped in the monitor? If several processes are suspended, then how to determine that which of the suspended processes should be resumed next? So for example, in this P1 and P2, for example here P1 and P2, so P1 has entered here, so it all executed the task, so then it has to come out. So due to some of the problems, still that monitor makes that P1 has to stay back there only. So then P2 is allowed to enter into the monitor, that is the P2. Okay, so here it is both the P1 and P2 as arised in the state. So then what the problem it is going to do, that if several processes are suspended, then determination of the process should be resumed next. So either if it is 2 or in the P1 and P2 it is in the monitor state. So if the problem what is it is facing in the monitor, it is resumed that problem. So then it is again the decision to be taken by the monitor itself. Either P1 has to be execute and can be give out and from the monitor, or P2 can be execute and given out from the monitor. So this is what the problem it is going to face by the monitor. So one solution, use an FCFS ordering, that is the process that has been waiting the longest is resumed first. So what is the solution for this problem? So which is the first come first serve ordering? For example, here P1 has first come into the monitor. So P1 has first came into the monitor and it is waiting for the long period of time. So P2 then it is entered into the monitor. So which is came the first, that is a first come first serve. So that has to be given, that has to be released first. Next solution, so either you can use this first and first serve concept or use the conditional wait construct, that is x dot wait. So or you can use the condition that is wait condition. So wait of C, here what is an C? It is an integer expression evaluated when the wait operation is executed. So here C stands for an integer expression. Okay, so what is this integer expression? So it can be evaluated when the wait operation is executed. So in the wait operation, so we know that to enter into the critical section it has to execute the wait operation. So during that execution of the wait operation, so we are going to evaluate the integer expression value. So next value of that C, that is a priority number, is then stored with the name of the process that is suspended. So once we have doing that, the process is entering from the entry section to the critical section. So it is going to execute the wait condition. So while executing that wait condition, so that particular name of the process it has to be stored in the some storage. So that whatever that process which is stored in the storage, it has its own unique ID or it has its own priority number. For example, P1 has 1 as a priority number and P2 has 2 as a priority number. So in case to solve this particular problem, we can going to use the priority number, that is which one has the highest priority number, it can be suspended first from the monitor. Where X dot signal is executed with the smallest associated priority number. So here X dot wait it is executed with the highest priority number and X dot signal it is executed with the smallest priority number. So why? Because we know that X dot wait it is used to execute from entry section to the critical section as it is entered first, and this X dot signal it is executing from that is a critical section to the exit section. A monitor to allocate the single resources. Okay, so for example here it is in a monitor. So this monitor it has to allocate the single resources. So there will be single resource needs to allocate it to the P1. Okay, so here A is a resource which is available here. So P1 cannot directly access the A1 resource, so it has to access the A resource through the procedure. Okay, so here P1 is requested to access the A resource through the procedure here. Through the procedure here. So we'll see that simple code that how we are going to allocate the single resources. So first you use the boolean value busy and condition x void acquire. So if busy, so if it is in a busy, if that resource, so is, for example, P1 is requested A. Okay, so A is the resource which is requested by the P1 here. So if that P1 is already busy, okay, so it is not able to give its resource to the P1, so then it has to wait for the some time. So if it is busy, then it will going to execute x dot wait. It has to wait for some time. So that busy is true. So it is waiting till it is busy. So it has to wait until that particular resource has to be unlocked by the any other process which is already utilizing. Then if it is done, then it will going to call the release method. So what is that release method? Busy is equals to false. So where if that busy is equal to 3, then the process has to wait there. Here void release, that already it has done the task and it is going to releasing now. Here the value of the busy is equal to signal. As we know that to release that signal, the value is equals to false, then we need to call the signal operation. So it is to call the signal operation to unlock the particular resource which is already taken by the any other process. So if it is executed, so then the complete code execution initialization code can be executed. Yes, here r dot acquired, so resource which is going to be acquired by any other process T for a particular amount of time, is the resources. The particular process has to wait until that particular resource has to come out from there, then it will going to access the resources. Once it is access the resources, so particular task has been completed here, so then it has to call the release operation to release. Here R is an instant of type resource allocator. So here R stands for an resource allocator. Following problems may occur during the resource allocator. So in this, some of the problem may occur during the allocating the sum of the resources. A process, it may access the resource without gaining the access permission. So either the process, it may going to access the any resources without gaining the permission, or it can never release the resource once it has been granted. So what the resource will do, it will going to never release that. So it is already utilized by the some of the process and the work is done. So but still some of that process, it is not going to release that resources. So that one of the problem. And a process may attempt to release the resource that it never requested. So until any process, it is not going to give the request to the resources. So until that time, the process is not ready to give the resources. And the process, it may request the same resources twice. And also a process P1, it is already utilizing the resource R1, it has completed the task and it has released the resource. But still again that particular P1, that is the process, again it is requested the same resource. That is what it is requesting, the same resource either twice or thrice. Again it causes one of the problem during the resource allocation. This completes your second module, that is multi-threaded programming and the process synchronization. Okay, so we have done with the second module. Okay, so I will give you the assignment of the second module by the end of the today or tomorrow. So you have to write the complete second module question and submit within the second IA. So I will give you 1 week time. You have to write and submit it to the MS Teams itself. Yes, you have any doubts in the second module, or else can I start with the third module? Yes, can anyone briefly tell out that whatever the concept we have studied in the second module? Yes, look into your book, whatever you have written. Just look a quick look on that, whatever the concept we have discussed in the second module. Is it I'm audible to you?
Yes, ma'am.
Yes, can anyone tell the whatever the concept we have done? At least in the after the process synchronization. No need in the multi-threaded programming, just tell me the process synchronization. Yes, Ravichandra? Bhargav Reddy.
Present.
Attendance ಹೋಗ್ತಿಲ್ಲಪ್ಪ. Bhargav Reddy. Attendance ಒಂದಕ್ಕಷ್ಟೇ ನೀವು ಅನ್ಮಿಟ್ ಮಾಡೋದಷ್ಟೇ. Yes, I am audible to you, Bhargav Reddy.
Yes, ma'am.
Can you tell what are the concepts we have done in the process synchronization? Yes, Likita bhai. Likita.
Yes, ma'am.
Can you tell which are the concepts we had done in the process synchronization? Okay, at least tell what are the solution for the critical section problem. How we are going to solve the critical section problem? Yes, tell me.
Mutual exclusion.
Okay.
Process, then bounded weighting.
No, that are the three requirements. It is compulsory. We are required to solve the critical section problem. So I am asking that what are the solutions for that critical section problem? Whatever you
Hardware
answer.
solution and Peterson solution.
Yes, hardware solution and the Peterson solution. So what the solutions we are going to given in the critical section problem. So and we have seen the semaphore also. So by using some of the semaphore values, that is the weight and the signal. So we have seen that how you are going to solve the critical section problem again. Next, in the classical problem of synchronization, can anyone tell what are the classical problem of synchronization? We have done the three problems of classical synchronization. One is the bounded buffer problem, and second one is the reader writer problem, and which is the third one?
Dining philosopher solution.
Yes, third one is the dining philosopher solution. So these are the classical problems of the synchronization. Okay, and last we have discussed with the monitor. So in the monitor there will be shared variables and as well as the procedures. Those procedures we are going to call it as an functions. There also, by using that particular monitors, we have solved some of the dining philosopher problem. So yes, you have any doubts, or else can I start with the third module?
No doubts.
Yes, at least you people replied in the chat box. Yes, others, at least you people replied in the chat box. Yes, okay. The next chapter, that is the deadlocks and the memory management. So the here in the third module, we have the two different chapters. One is the deadlock and the memory management. Okay. So in this deadlock, you are going to study the what is the definition of the deadlock and the system model of the deadlock, and you are going to study the characteristics of it and what are the methods you are going to handle this deadlock and how you are going to prevent the deadlock and how you are going to avoid the deadlock. And also you are going to study the deadlock detection and the recovery from the deadlocks. Okay, so this complete description about the deadlock you are going to study in this first chapter in the third module. Okay, so first we will understand that what is the deadlock, and we'll tell the some real time example to understand the deadlock. So let me see that what is a deadlock here. Okay, so we call this deadlock, it is a problem, or we can going to call it as a condition or situation. So it is either a condition or it is a situation. Okay, so deadlock is a problem and it is a condition or it is a situation when two processes is going to share the same resources. When two different processes are going to share the same resources, so these are effectively preventing each other from accessing the resources. So let me tell one real-time example that how we are going to see the deadlock here. So here, for example, take that there will be a one road as there. So let me take it as a road. So here one vehicle is coming in this side and again one more vehicle is coming in this side. Okay, so both these two vehicles has to reach by this opposite direction. So let me take it as an user 1 and is the user 2. Okay, so both user 1 and user 2 is coming in the opposite direction in the same road. Okay, so either user 2 has to go this side by using any other space, or user 1 can go this side by using any other remaining space. So but already whatever the space it is there, it is already filled by the other vehicles. Okay, so then what will happen, either u1 has to come back to this road or u2 has to come back this road. Okay, but no one user is ready to come back here. Okay, so this particular situation we are going to call it as a deadlock situation or it is a deadlock condition. I will repeat once again. For example, user 1 and user 2 traveling in the same road, so they are not able to reach the road by using any other space because already all the vehicles are occupied here. So then that particular state, what we are going to call it is a deadlock. Okay, so this is one real-time example. So and one more example, let me take the phone call. So what is that phone calls? For example, A here is and B here. So for example, A is dialing the number to call with B, and the same time what the B will do, B is dialing the number to talk with the A. Okay, so at the same time these two persons are going to make a call here. So at this again both this A and B, it is going to get the engaged or they are going to get the busy condition. So that particular state again we are going to call it as a deadlock. So A is going to call the B and the meanwhile same time B is going to call the A. Okay, so at the same time both are can be engaged here. He is not able to talk with him and he is not able to talk with him. That particular condition we are going to call it as a deadlock. Okay, so let me take that process P1 and take the resource R1 and take the resource R2 and take the resource P2. Okay, so before that, take down the definition for deadlock. Yes, I've understood this concept. What is a deadlock?
Yes, ma'am.
Take down the definition. It is a problem. It is a problem, comma, a condition or situation when two processes sharing same resource. when two process sharing same resource. So here what is the same resource? Here the mobile number, it is whatever they are both are doing, it is in the same. And again, what is the same resource here? So what is the road that two users can be taken to travel here? So that is the common resource here. It is a problem, comma, a condition or situation when two processes sharing the same resource are effectively preventing each other or effectively preventing each other from accessing the resources. From accessing the resources. Yes, there take down or. So there you take down this. Deadlock is a situation where a set of processes are blocked. So till here 2 points you take down this. Deadlock is a situation where a set of processes are blocked. Set of processes are blocked because each process is holding a resource. Each process is holding a resource and waiting for another resource. And waiting for another resource. Waiting for another resource held by some other process. Held by some other process. So this is a real-time example we have seen. So now we will see the example of a situation where the deadlocks will occur. Okay, so this is the diagram for that. So take down the example of a situation. Example of a situation where deadlocks can occur. Where deadlock can occur. Okay, so there you take down this diagram. So here there will be two resources are there, R1 and R2, and two process, that is P1 and P2. Okay, so here first the R1 resource. Okay, this R1 resource, it is allocated to the P1 here. Okay, so let me write here R1 resource allocated to P1. Okay, so R1 is the resource which is allocated to P1 here. Okay, so this is the first step. And again, but this particular P1 process, what does particular P1 process it will do? But this P1, it is requesting the R2 resource. This P1, it is requesting R2 resource. Okay, so that is the second point. So, and again, here R2 is the resource, it is allocated to P2. R2 resource, it is allocated to P2. Okay, so again here P2, but it is requesting for R1 resource. Here P2, so let me take this as a third step, and here P2, it is requesting P2, here it is requesting for R1 resource. Let me take it as a fourth step. Okay, so see here, even two resources are there, R1 and R2, two process P1 and P2. Okay, so P1, it is already allocated to R1, that is already allocated to P1 here. Okay, so now P1 is holding the R1 here. Okay, so let me write that P1 holding R1 now. Okay, so why? Because R1 it is already allocated to P1. So but what the P1 is required? So P1 is requested for the R2 resource. Okay, so but P2 it is requesting for the R2 resource. Sorry, P1 it is requesting for the R2 resource. It is requesting the R2 resource. Okay, but R2 it is already allocated to the P2. This R2 resource, it is already allocated to the P2. Okay, so now again what the P2 it is doing here? So P2 it is again it is requesting the R1 here. Okay, so this complete state we are going to call it as a deadlock here. So why? Because one and the other process or the resource, it is depending on the other or any another. So here resource R1, it is giving on the P1, so but it is depending on the R2, and again this R2 it is given on the P2, but it is depending on the R1. So this is the state where we are going to call it as a deadlock state. Okay, so because no one it is an independent here, so one in the another way every resource or the process it is going to depend on any other resources. So this complete state we are going to call it as an deadlock state. Okay, so it on one again repeat one this real time example. So let me take a road or any train. So in the same line, in the same path, if the two different user 1 and user 2 are traveling in the same path, so if there is no space to reach by the other side, so that the particular space what is we are going to face here, we are going to call it as a deadlock. Okay, so this is the example. Yes, so this is the example where the situation how we are going to face the deadlock. Next we'll see the system model. A system consists of the finite number of resources. These resources are distributed among the number of systems or number of processes. So for example, we know the difference between the process and the resource. Okay, to execute the particular process we have some of the resources, right? So let me take that we have required some of the resources. For example, computer. So I need to take the printout from the computer. So in one and other way, so one process will going to request the any other resources. So here a process must request a resource before using it. So the any process it will going to request the resource. For example, computer is the process here. It is going to request the resource printer before giving the printer to the user, and it release the resource after using it. So then computer will going to unlock the particular whatever the printer, so after it is given the printer to the user. A process can request any number of resources to carry out the given task. There is no any limited number of resources needs to be taken by the process. It can take the any requested number of resources. The total number of resources requested, it must not exceed the total number of resource available. So for example, so the total number of resource requested, so there will be only R1 and R2 is only two resource available to the process P1. So what the process P1 do, it can going to access that R1 R2 and again it is required the R3. It is not possible. It should not be exceeded the total number of resources available. In normal operation, a process must perform the following task in the sequence. So in the normal operation, what the process it will going to do. So process first it requests the resources, and the process it will going to use the resource, and the process will going to release the resource. This is the three main different operations or three main different tasks which is going to taken by the process. What the process will do? Process will request the resource and the process will use that particular resource, and again once it is completed the process will going to release the resource. So if the request cannot be granted immediately, then the requesting process it must wait for acquiring the resources. If that process it is requesting the resource, it may not be sure that you are going to get the resource immediately. So because that resource which is already utilizing by the some any other processor, so then what you have to do, so you have to wait for some amount of time to get that particular resources. So for example, you can use the open or malloc function, new function and request function. So these are the examples that how you are going to do the request. So if that resource it is already available, so then you are going to use the open function. So if it is not available, then you are going to give the request to that resources, then you are going to get the resource. And what once you have received the request, you are given the resource, then you have to use that. The process use the resources. Example, print to the printer or reads from the file. So for example, here computer is requesting the resource printer. So now it is available to the computer, that is printer is available to the computer. So what the process that is the computer will do, it will give the printer to the user. So it is the state what it is, the process is using the printer here. So once the printing the sheet or printing the file is done, next what the process will do, he will going to release the resources. The process, it will release the resource, so that resource become available to the other process. So if that particular mine work is done, so then what I will do, so I will release that. So for example, if I'm taken that second hour class, my portion is completed, so then what I will do, I will leave you the people, so the another person, another faculty can going to engage by the third hour. So whatever the resource I am released here, whatever the class I am released here, so that can be utilized. Or example, how you are going to release, you can use the close function or free or delete or release. So these are the functions you can use to do the release operation. So just take down heading request, there copy the example, open new request and malloc. Next in the release, take down the example, close, free and the delete. Just make a note of it. Next concept is the deadlock characteristics. Okay, so in the deadlock characteristics, there will be a necessary conditions and the resource allocation graph. So these are the characteristics of the deadlock. So inside again in the necessary conditions, you are going to see some of the conditions are necessary to achieve the deadlock. Here mutual exclusion, hold and wait, no preemption and circular wait. Okay, so these are the four necessary conditions to achieve the deadlock. So take down heading deadlock characteristics. First one, necessary condition, followed by resource allocation graph. So there are four conditions that are necessary to achieve the deadlock. First one is the mutual exclusion. Okay, so these are the four conditions for the deadlock. So first we will see that what is mutual exclusion. So we know that what is a mutual exclusion, so that only single process can be able to enter into the critical section. Okay, so here this mutual exclusive, it is not an shareable, so it is not a shareable. So for example, let me take R1 is the resource here and P1 is going to accessing that resource. So if the same time P2 has came to access the resource, it is not possible because this mutual exclusive, it is not shareable. So it doesn't going to share the any data. So this resource cannot be shareable between the any two other processor. Okay, so then there, if it is a shared variable, if it is a shared memory, then you are going to face the deadlock condition. Next is the hold and wait. So in this hold and the wait, so whatever the same example I given that there will be two different resources, R1 and R2 and P1 and P2. Okay, so the same resource like R1 is the resource which is holding by the P1, and but P2 is requesting the R2, and R2 it is holding the P2. So but P2 in turns again holding the resource R1. So here no one resource can be able to execute independently. So one is depending on another, and again another is calling another. So everything in it is going to be dependent on one on the other way. So in this here, this R1 it is already holding by the P1, but P1 is requesting the R2, and again this R2 is holding the P2, but P2 is requesting the R2. So this is one is holding and another is waiting. So here P1 it is already holding the R1, so but still that P1 again it is waiting for the another resource. Okay, so this is the one condition that it will going to make the deadlock here. So next third one is the no preemption. So what is this no preemption? So for example, resource are there and process is there. Okay, so if that particular resource it is utilized by the process, so then by voluntarily the resource can be voluntarily released by the process. So if that whatever it is required, how much of time that process P1 is required that resource, so if that task is done, so by voluntarily this resource is going to be released by the process. So what the P1 will do, so my work is done, what is it is get taken by the resource, now I am going to release or by voluntarily this particular R1. Okay, so that particular R1 it is voluntarily released by the process itself. Okay, so that we are going to call it as a no preemption. So we are not forcefully removing the any resource here, by voluntarily the process is going to release the resource, then we are going to call it as there is no preemption. And next in the last circular wait, so let me take that example. So for example, A is a process here. Okay, so A is acquiring the B process, it going to acquire the resources which is needed by the B. So what the A is doing here, A is acquiring the resources which is needed by the B, and again B is acquiring the resources which is required for the C, and C is acquiring the resources which is necessary and which is required for the D. In the same manner, D is acquiring the resource A, so which is needed by the D itself. Okay, so this is what a circular manner. So here also we are going to make the condition that is a deadlock. So for example, so in one another way, A is going to acquire the resource B, it is going to acquiring the resource B, so which is needed by the B here. So it is going to acquire the resource, but it is required by the B, and again B it acquire the resources which is required by the C. So in one another way, it will going to make a circular wait or in the circular queue. So one has to wait until another any releases, so that has to wait any another previous resource has to be released. Okay, so this condition again it will going to met the deadlock. So these are the four different conditions, so which is going to be causes the deadlock if it is a not shareable, hold under wait, no preemption, and as well as a circular wait. Okay, so this is the first, and the second is the resource allocator graph. That resource allocator graph I will start in the next session. Next is the resource allocation graph, so that I will start from the next session.